In this lesson, I'm going to be showing you how to use algebra tiles to solve algebraic problems. But first, I need you to be able to identify the different types of tiles that we're going to use for this sort of problem. The tile on the left, the not filled in tile, or the white tile, represents +1. The filled in tile represents -1, and then of course we have our rectangles, which is represents our variable tiles, our letters. So let's move on to a problem. In the first problem, I will have x plus 3 equals 5. The first thing we need to do is model this using the tiles that we have in front of us, or that we just discussed. Once again, our dividing line is going to go right down here by the equals. So first we're going to list in 1x, one variable tile, and then 3 positive tiles, because we have +3. Remember that the positive tiles are not filled in. On the right-hand side, I have +5, so 5 positive tiles. Now what's the goal in algebra again? You're right. The goal in algebra is to get the letter by itself, which means that I need to get rid of the white tiles that are next to the variable tile on the left-hand side. Now, when using algebra tiles, we never just get rid of tiles. There's a system we need to use, and there's a system that's called zero pairs. Now, a zero pair is the idea that if you have a positive tile and a negative tile, and you put them together, what do you get? The answer is 0. Because +1 and -1, when you put them together, gives us 0. Just like if I have +2 and -2, or +3 and -3, they will always cancel out. So we're going to use this idea of zero pairs, this idea of tiles that cancel each other out, to solve the problem. What we need to do to get rid of then the white tiles that are by the x are to make 3 zero pairs. So on the left hand side, to do that, I need to put in 3 more dark tiles. Because if I put in 3 more dark tiles, I then have 3 zero pairs. And just like when we use balance scales, what you do to one side, you have to do to the other. So if I put in 3 dark tiles on the left, I have to put in 3 dark tiles on the right. So we're going to do that now as well. Okay, because the combinations of zero pairs mean 0, they mean nothing, we can now cross them out. So +1 and -1 is 0, it's nothing. +1, -1, 0 and 0. 0 and 0 and 0. So what do I have left? I've got x on this side equals 2 more white tiles, so +2. Let's try another problem. In this problem, I'm going to have n minus 4 equals 3. We're going to follow the same principle. First, let's model. On the left, I've got a variable tile of n, and this time I've got -4, not +4. You see the minus there, so -4. So I need to put in 4 filled in tiles, because that represents -4. However, on the right, I've got 3 positive tiles. There's no minus there. So I'm going to do 3 of these non-filled in tiles. Now again, we want to get the variable by itself. So to do that, we have to put in the zero pairs to make that happen. If I've got 4 black tiles, or filled in tiles on the left, to balance it out and get 0 pairs for all of them, I need to put in 4 more of the non-filled in tiles. What I do to the left, I do to the right, so I'm going to put in 4 more of the not filled in tiles on the right. Let's go ahead and get rid of any 0 pairs we have. 1, 2, 3, and 4. So all the 0 pairs are gone. There's no 0 pairs on the right this time. What do we have for our answer? N is 7 white tiles, or +7. Well, what happens if we have a two-part equation? We'll take a look. 3n plus 1 is 10. Once again, the problem we've used in many examples in the last few videos. let's model the equations first. Well, how many n's do I have here? Well, according to the equation, I have 3 separate n's because it says 3n, 3 groups of n. So I have to write that out as a variable tile of n, a variable tile of n, and another variable tile of n. And then we can't forget about the plus 1 because that's part of this side of the equation as well. So I've got 1 non-filled in tile. And then, of course, on the right, I've got 10 positive tiles. So we need to represent that as well. 5, 6, 7, 8, 9, 10. Okay, the idea is to get the letters by themselves first, so we have to get rid of the plus 1. Let's put in a 0 pair to make that happen. Oops, use a different color here. Put in a 0 pair to make that happen on the left and on the right. Of course, now we can cross that out. Perfect. What do we have left? Well, each n has to have the same amount of tiles to be able to figure out what one n equals. I've got 9 tiles left on the right hand side. You can see that these tiles have already been organized so that each n gets 3 tiles, or an equal amount of tiles. So if each n gets 3 tiles, we can say that one of them gets 3. So 1n, which is what we're trying to figure out, is 3, or 3 positive tiles. Let's verify and check. 3 times 3 plus 1 is 10. Yes, that's what we had originally, so we found our answer. This is how to use algebra tiles to solve algebraic equations.